Welcome to the Beaver's balance. Here, along this luminous riverbank, beavers carefully weigh unknown bundles of reeds against tidy, known piles on a wooden scale. When the scale sits perfectly level, both sides are equal. That balance represents an equation, where exactly one definitive bundle size keeps the beam perfectly flat. But when the weight shifts and one side drops, we have an inequality. The unknown bundle isn't just one weight anymore. It represents a whole set of possible heavier or lighter values. To track this range of possibilities, we move away from the physical scale and map the solutions onto a number line. Mathematical expression work gains its value when we can visualize the structure and meaning behind the notation. This is a number line etched into the sand, and our problem is to graph the inequality. X is less than 4. This inequality encompasses every possible number that is smaller than 4. To show this on the graph, we place an open, hollow circle exactly at the 4. This indicates that while 4 is our boundary, the number itself is not part of the solution set. Next, we shade to the left, capturing all the values that are smaller than our boundary. Our final graph uses an open circle at 4 and shades to the left. Let's try another one on a number line featuring negative integers. X is greater than -2. We place an open circle at -2 because the inequality is strict and the boundary is excluded. Since X is greater than our boundary, we shade to the right to capture all values larger than -2. To complete the graph, we use an open circle at -2 and shade to the right. The graph reveals the entire solution set at once. The direction of the shading shows us exactly which side of the boundary holds the valid answers. Here is a completed graph. It has a solid, closed circle at the number 5, with an arrow extending to the right. Which inequality does this represent? Take a moment to pause the video and try to translate this graph back into an algebraic expression. The visual evidence tells the story. A solid, closed circle indicates that the boundary value of 5 is included in the solution set. The shading moving to the right signifies values that are greater than the boundary. When we combine these pieces of data, we find the inequality is X is greater than or equal to 5. Moving effortlessly in both directions, from an inequality to a graph and back again, is a core part of mathematical fluency. This chart summarizes our rules. The less than and greater than symbols use an open circle, while the or equal to symbols require a solid circle. Shading follows the same logic: left for less than values and right for greater than values. This expression records the specific relationship between an unknown quantity and its boundary. Shading these boundaries builds a bridge between simple arithmetic and the formal variables used in algebra. Connecting an inequality to its graph ensures the symbols on the page represent a clear visual reality.